Oh, it is recording. Hi, everybody. This is Mrs. Lehman from Math with Mrs. Lehman. I hope everyone's having a great day. I'm here with my third period class.
Hello.
I figured we'd start today's video off a little bit differently than other days. Some students have some really wonderfully corny jokes that they would love to share with you. So Liz is our first comedian here. Here you go, Liz.
Why does a duck have feathers? To cover his butt quack.
All right. I hope you're all clapping your knees at home. And next up with corny joke number 2 is William.
What did the red light say to the green light? Don't look, I'm changing.
Now, not only can you watch Math with Mrs. Lehman for good math tips, but you can also use Math with Mrs. Lehman for your source of corny jokes. So thank you guys. Let's hear it for Liz and Will. Fantastic, fantastic. Okay, now we're going to get down to business here, and we are going to do the bell ringer, which is to find the area of the parallelogram below. So I'm pretty proud of my fancy smartboard skills here. Look at that. That was magical. So with a rectangle, we find we use length times width, right? Because if we were to chop this section over here off, right, we would essentially have a rectangle. That's why we're always looking for the set of lines that form what type of angle, everyone?
Right.
A right angle. And what do we call lines that form a right angle? Not everyone at once, kids. 2 lines that form a right angle are called, Justin.
Perpendicular?
Very good, perpendicular. So, which 2 lines here are perpendicular to one another? What are the lengths of those 2 sides, I should say? Mackenzie, what are they?
11 centimeters and 4 centimeters.
Very good. These 2 lines form right angles. So it would be 4 centimeters and 11 centimeters that you would use. Now we need to put the formula for a parallelogram, which is base times height. The area equals 11 times 4. What is 11 times 4, everyone? 44. 44. And what unit would we need for this? Tim, nice and loud. Very good. Centimeters squared. And what that means is if we had 1 centimeter by 1 centimeter little squares cut out, we would need 44 of those. Oh man, that did not work how I wanted it to. We would need 44 of those. Let's pretend that was to scale, to cover that entire parallelogram. All right, so how much would it take to cover the surface? Any questions there? All right, we're going to move on to solving the equation. Whenever we have an equation, your job is to isolate the variable, meaning what? When I say isolate the variable, what do I mean by that? Elijah.
Get the variable by itself.
Very good. So we're trying to get a on one side of that equal sign and the numbers on the other side. So we're going to get a by itself. So to do that, what do I need to do with the 4 times a? To undo that, I do what?
Divide by 4.
Divide by 4 on each side. Very good. So we have a equals, and what would that be? Liz. Oh, I'm sorry, Julius, I haven't heard from you yet.
13.
13, very good. So area, or not area, A equals 13. And what would our unit be, Liz?
Square?
What squared? Oh, what am I doing? Wow, rewind the tape. I'm so stuck on area. There's no units here. Derp. All right, this is where I wish I had an editing button because I'd edit that out because that was a yeah, that's why Liz was very confused because it made no darn sense. So I'm getting a slow clap from Jaden. Thanks, Jaden. I can count on you. All right. If we were finding area, it would be units squared. But since we're not, and we're just finding the value of A, just never mind, leave me alone. All right, write an expression to represent Carrie's age. Carrie is 3 years younger than twice the age of her sister, Helen. All right? Who thinks they know what this would be written as an expression? Jaden's ready to not only pick on me, but give the right answer here. What do you think, Jaden?
2h minus 3.
Very good. I agree with you. So, there's some key words here. It says Carrie is 3 years younger than. That word than is a clue word to tell you to, I wish you could see Jaden right now. She is doing a wild flip-flop dance in the back of the room, telling us that that's a flip-flop word. It's not really that wild of a dance. Just waving her arms around a little bit. It's like twist of the wrist. Oh, everyone's busting out some moves. Wow, I wish I had a camera. All right, but the year is 1902. We have this lowly smartboard recorder. Anyway, that's okay. All right, I'm just picking. It's pretty great technology. So, twice is the other part. Twice of, take Helen's age, you have to double it, right? Twice means you multiply it by 2. So you have 2 times Helen. And then this than word is a flip-flopper, hence the dance moves. All right, so we have 2 times Helen and then subtract 3. So let's hypothetically say Helen is 4 years old. All right, how old would Carrie be? Be careful.
Oh, wait, no. Should be.
If she's 4, 2 times 4 minus 3, you'd have 8 minus 3, she would be 5. Uh-oh, that's contagious. All right, any questions on that? We are going to practice these some more each day. But anyway, we are now moving on to our joke of the day, which shows a teacher showing the kids different types of triangles based on side length. Equilateral means all of the sides are the same length. Isosceles means 2. Very good. 2 sides and 2 angles are equal. And scalene means none of the sides are equal in length. And then this young man in the front of the class raises his hand and says, "You forgot Bermuda."
Bermuda Triangle.
I know. You guys are rolling over in laughter. Okay. All right, is this a question for video or no? Comment? Yes.
My teacher in 4th grade, she said to remember Scalene. She had a kid named Kayleen, and she was the only one with that name, so she said Scalene, Kayleen. She was the only one. So.
Oh. I don't know what I'd think of that if I were Kayleen. I don't know if I'd like that. I don't know what I think about it. Okay.
I would not
All right.
be okay with that.
I don't know. Okay. Anyway, we're going to find the area of right triangles, so expect your mind to be blown right now when I draw this beautiful example of a rectangle. You're on page 7, by the way. All right. Now, let me draw this one in red. Okay. So I have a rectangle up here, and we know the formula for the area of a rectangle is what?
Length times width equals area.
All right, the area of a rectangle is length times width. Now, a triangle, look at this. What? All right? What do you think the area formula for a triangle would then be? Not everyone at once. I mean, really. What do we think? I'm coming back to Jaden, even though she picked on me. Here you go, Jaden.
Since it's half of the rectangle, it would be half of the area of the rectangle, too.
Very good. So there's 2 ways we can kind of approach that. All right, so we're going to take half of that rectangle. You're exactly right. Now, to do that, I'm going to erase those. That was lovely. All right. We're going to write both of these down. We're going to take the area of the rectangle or parallelogram base times height, and we're going to take half of it or divide it by 2. Now, this formula, this first way it's written, is useful when you have whole numbers and decimals, in my opinion. The second way of doing it is helpful when you have fractions. If we divide something by 2, we're splitting it in half, right? So we're taking half of something. So 1/2 base times height. Mathematically, they are the same value, okay? They both represent the area formula for a triangle, but it's kind of like, you know, dependent on what your numbers are, which one would be most useful to you, okay? So again, this first example, BH divided by 2 is good with whole numbers and decimals. The second one is great when you have fractions to work with. So let's go ahead and look at example 1. All right, which one would we want to use for example 1 or exercise 1? Would we want to use the first formula or the second formula? Timothy, the first one, very good. What about exercise 2? What do you guys think?
Second.
The second, because it has fractions. And the last one, exercise 3, would be what? I'm hearing both. What do you guys think?
2.
I would use the first one myself, all right? Because I don't want to mess with the fractions unless I really have to. All right, so what you're looking for is the same with the parallelogram. You're looking for perpendicular lines. You're looking for that right angle. And they're starting you off with just right triangles, but, you know, be prepared. Tomorrow we're going to learn, for example, if we had something like this, you'd still look for the, you know, the base and the height being perpendicular. Does that make sense?
Yeah.
You have to be ready for these things to be, whoops, let's get rid of that. Delete. You have to be ready for things like this to be rotated, okay? So it really throws a lot of kids off if they see, you know, the triangle other than in this state. They might see it like this and they're like, oh my goodness, there's no base and height. Yes, there is. You just, that right angle still exists. It's just, you know, with this line and this line, it looks like it's tilted differently, but it's still a right angle there. Does that make sense, everyone?
Yeah.
Okay, so they make it really easy on you today. So it's just a lot of calculating today, plugging in and calculating. So we're going to write the formula always first. So area equals base times height divided by 2. And then you're going to plug in. Which two numbers do we want to use for the base and the height? Liz.
15 times 8.
Yep, 15 and 8, because those are the perpendicular lines. Right, so 15 and 8. So 15 times 8 divided by 2. Your first step is to write the formula. Step number 2, you have to identify what your base and your height is. Step 3, plug it in. Step 4, now you're going to start your calculation. So 15 times 8, we're going to go ahead and do that. You get 120. So we have 120 divided by 2. And 120 divided by 2, or half of 120, is 60. Very good. And what unit would we want here? Willow, nice and loud. Feet squared. Very good. That's as loud as Willow gets, by the way. You're a cheerleader, aren't you?
Yeah, she should do it.
Shout it out. All right.
Top down.
All right. So anyway, 60 feet squared, and that would mean 60 1 foot by 1 foot square sections would need to be used to cover that triangle, not drawn is actually. All right. This next one, we have some fractions going on. Which two numbers are we going to want to use for our base and our height? All right. Elijah.
8 and 2/3 and 5 and 3/5.
Very good. Again, looking for that perpendicular line set of perpendicular lines. You know what I mean. All right, so area equals 1/2 B times H. All right, let's plug in. We have 1/2. The base is 8 and 2/3 times 5 and 3/5. Well, if we had our scientific calculator, we would just have some punching in to do here, right? And that'd be pretty easy, but let's say we don't have a calculator. We need to put these fractions in the correct form to be multiplied, to have their operation. What do we need to do? I have a lot of shy students this period. Yes?
into improper fractions.
Thank you, Jasmine. Very good. Turn them into improper fractions. So 1/2 we don't have to mess with. It already has just a numerator and a denominator. We want to make this 8 2/3 just have a numerator and denominator. So 8 times 3 is what? 24 plus 2 is 26. You keep the original denominator. All right, times 5 times 5 is 25 plus 3 is 28 over 5. All right, so this is where kids start to lose their minds. You can simplify before you multiply. So essentially you're looking at numerators and denominators and looking to see if a numerator and denominator share a common factor. So you're really lucky that this is a 2 because anytime you see an even number, you can essentially chop it in 2. So is 26 an even number?
Yes.
Yes, it is. 28 is also an even number. So I could split either one of those. So 2 goes into 2 one time, and how many times does 2 go into 26? 2 times what gives us 26? 2 times 3 gives us 6.
Oh.
We're struggling today. It's 13. All right. So, who was? Not me.
What?
Jaden's was right here. She's like on our cases. All right. No one make a mistake around Jaden. She's on you. All right. Again, I wish you could have a camera right now. You'd see a big old smile on Jaden's face, and it's a lovely sight. Now she's trying not to smile, which is equally funny. All right. So anyway, you know who has the best straight face ever? Julius.
Remember that one day?
All right, yeah, we cannot make him break that face. All right, that sounded bad. I don't mean break your face. I mean break break into a smile. See, I can't even. Julius. See, now he's starting to smirk a little bit. I'll stop harassing you. All right, here we go. Anyway. We all really enjoy each other's company, I think, in here. Either that or they are lying to me with their smiles. No, we cannot simplify 28 because 28 does not have a factor of 3 or 5. We already used the 2. Okay? Any questions on that? Good question. I was wondering if someone would ask that. All right, so 3 times 8 is 24. Carry your 2. 3 times 2 is 6. Plus 2 is 8. Put a 0 down because now we're multiplying by our tens place. So 1 times 8 is 8. 1 times 2 is 2. You ever just second guess yourself? Like, did I do something wrong there? No, I'm just double checking real quick. Okay. 4 plus 0 is 4. 8 plus 8 is
16.
Carry your 1. You get 364. All right. So 364 over what? What's 3 times 5?
25.
Yikes. 15. Slow down and get it right, okay? 364 divided by 15. Okay, because we would not want to leave our answer like this, okay? We want to now turn it back into a mixed number. 15 goes into 3, no times. It goes into 36, how many times, everyone? Twice, 2 times, that gives you 30. Subtract, you get 6. Bring down your 4. How many times does 15 go into 64? 4 times. Thank you, William. 15 times 4 is 60. Subtract, you get 4. What do I do with that? I don't want to put remainder 4. No, I'm not going to. The reason I'm not going to do a decimal in this case is because chances are if this were a multiple choice type question, you were given fractions. Chances are you never know with the math wizards of the world, but you're going to get the answer as a fraction. So Jaden, nice and loud. She'll yell at me. 415. Very good. You're going to use this remainder as your numerator and this number in front as your denominator. So that equals 24 and 4/15, and our unit will be meters squared. All right? Any questions? Alrighty. We have this last one. We've got lots of time. So, now, We have a choice again, which formula we'd like to use. First one or second one? First one, yeah. So base times height divided by 2. Alright, let's plug it in. The elderly amongst the viewers, including, that's me, I'm calling myself elderly. We're not elderly, but they would remember that commercial. Glade plugins. They're not even paying me to say that.
They're not.
They're not. They're not paying me. Although maybe one of the YouTube magicians is going to hear me say that on there. And then they're going to say every time that this video is played, Glade is going to get like a cent or something.
Hopefully.
That happened with one of my videos. It was something like I played some music or something and it identified it and it said that it was going to like reimburse. I think the Beach Boys. I was like, what?
Wait, what's Beach Boy?
The beach.
The Beach Boys. There's only the Beach Boys. All right, so we have some calculating to do. Just a little hint. I would put your easier number to multiply if the digits work out for you. Put that on the bottom because I'd rather multiply by 1. You know what I mean? See what I'm saying, kids?
Yep.
Doesn't matter technically, but multiplying by 1's like a breeze. 4 times 7 is 28. Carry your 2. 4 times 2 is 8 plus 2 is 10. 0, carry your 1. 4 times 3 is 12 plus 1 is 13. Alright, you're going to put a 0 placeholder. 1 times 7 is 7. 1 times 2 is 2. 1 times 3 is 3. Alright, put 2 zeros now. That's how that works. Alright, 2 times 7 is 14. Carry your 1. 2 times 2 is 4 plus 1 is 5. And 2 times 3 is 6. Now we have the task of adding. 8 plus 0 and 0 is 8. 0 plus 0 and 7 is 7. Alright, 3 plus 2 is 5. 5 plus 4 is 9. 1 plus 3 is 4. 4 plus 5 is 9. And we have our 6. Now, a lot of kids are still struggling with what do you do with the decimal point. The decimal is not a lining it up situation, just is a coincidence that happened here. What you're looking for is how many spots past the decimal there are. In this case, there are 2. So you're going to start at the end here after the 8 and move in 2 spots. And you will get 699 and 78 hundredths kilometers squared. Oh no, I didn't. What step do I still need to do?
Divide by 2.
Divide by 2. You know what? The math wizards almost got me. Actually, I almost got myself because that was pretty bad. All right, so 699 and 78 hundredths divided by 2. Any questions so far? I know we're moving quickly, but all right. Remember, does McDonald's sell cheeseburgers raw? Another shout out to Mickey D's. So we're going to divide by 2. Divide. That 2 goes into 6 3 times. Multiply. 2 times 3 is 6. You subtract, you get 0. Check and then bring down. So 2 goes into 9. How many times? 4. Yep. 2 times 4. When you multiply, you get 8. You have to subtract. You get 1. You're in check. Is 1 less than 2? Yes, it is. That means we can bring down this next number, the 9. All right. 2 goes into 19. 8 times. Nope, 9 times, duh. What am I doing here? Time for Mrs. Lehman to go home. All right. You wish. Hey, easy.
No, I wish we all went home.
All right, that's 18. Subtract, you get 1. Oh, don't forget to bring that decimal point directly up here. Bring down your 7. That would go in 8 times. That's 16. Subtract, you get 1. Bring down the 8. And 2 goes into 18 9 times. All right, so again, lots of little steps, but nothing too terribly difficult. So we have 349 and 89 hundredths kilometers squared. And I guarantee if this were a multiple choice question, one of the possible answers would be 699 and 78 hundredths because they're waiting for that kid to do what I just did and go, oh look, my aunt. my answer is there. Let me pick that one without really finishing the problem. Okay? And again, I do not care if you use a calculator for these things as long as you're showing all of the steps. Okay? So if you're utilizing a calculator, you would definitely need what I am circling in green right here. Okay? Any less than that, you would not be getting full credit for, because then you're just typing in something that I don't know. Okay? Any questions? All right, your homework tonight is to do page 9, which is the problem set. All right, calculate the area of each triangle below. Again, look at number 1. Oh no, the right angle is not at the bottom. It's okay, kids, it can be rotated. And then, let's see. Yeah, same thing here, number 4. You'll survive. You're looking for the perpendicular lines. Okay, so you're going to start with the formula for each. Let's get that started. All right, which formula do I want to use? I can use area equals base times height divided by 2, or area equals 1/2 base times height. Which one do I want for 1?
Number 1.
First one or second one, everyone?
1.
The first one. So base times height divided by 2. You're going to go ahead and plug in. Now you got to figure out which are the 2 perpendicular lines. In this one, which one would you use? First or second formula up here? The second one. Good. So 1/2 base times height. And then down here, I would use the first one for both of these. Area equals base times height divided by 2. Area equals base times height divided by 2. And then you're just going to identify. Why don't you guys go through and circle which 2 sides you're going to use as your base and height, right, for each of these. I'd like to thank you for watching Math with Mrs. Lehman. Thanks for putting up with, thoroughly enjoying all of my corny jokes and the overly contagious enthusiasm this class has right now.
Yeah.
It's like a Monday,
It's Tuesday.
but it's Tuesday. But they're acting like it's Monday, 7 a.m. or something. But anyway, they're doing a great job. Right, kids?
Yeah.
Yeah. Oh, yeah. All right, anyway, thanks for watching. I hope you have a great day. Don't forget to like and subscribe. Bye.
Bye. See you later.
Now they come to life.